So their approach is to have a single tier where you have like one constant set of nodes that you're looking at the scene. And it's capable of doing all these things. It should be capable enough to detect objects, recognize objects, and track objects if need be. So another approach is to have multiple tiers. This paper talks about 3 tiers. Have multiple tiers where the lower tiers trigger, I mean, they do something very coarse-grained. They are very capable, but they are less, they don't consume as much energy, so they can be around to do stuff. And then the next layers are more powerful. So if you on demand, you have the more powerful stuff. But for the lower level stuff, filter out a whole bunch of things, right? And their argument is this is the way to go for these things. Right? And there's a lot of examples of these kind of systems. If you imagine your TV or something, right? If your TV is switched on, the only button which really works is your on-off switch. So hopefully there's a little circuitry there just looking for on-off signal. Everything else is turned off on your TV, right? So once you press the appropriate on switch, then the TV comes on and it interacts with you, kind of stuff, right? So that's sort of their model. So you have these little sensors which all they do is like as little detection as possible, and as little energy as possible, as less cost as possible. But they have these other things on demand. So hopefully using this, you will be able to perform operations which you couldn't do in the one-tier model, because now you can use the resources of something which is far more stringent than what is available over here. So you can actually imagine a 3-tier where one is a very low power sensor. The next one is sort of like what you can have here. The third one could be like a PC or something. So you can get all the things on demand, right? The main concern that they have to worry about in all these things is the cost factor, right? You may want to have a single tier which is pretty powerful and get these things, but a single tier should be powerful enough to perform all these 3 operations, which means that their computing strength will be pretty good. So they'll also consume probably a lot more energy, so that means their product also be bigger, so their product also be more expensive. So for a given budget, this would mean that you can only have fewer sensors, right? Fewer sensors could mean that you don't either have good coverage or reliability is compromised because there's so few of them, you can knock so few of those and bring the system down. And also in terms of energy consumption, each one is big enough to perform all these 3 tasks. So if all you're doing is the simpler stuff, you're wasting energy trying to keep these things going, right? So that's what they were trying to show. There are other projects which take the similar approach, right? There's work done on laptops, like I mentioned, trying to figure out where you're facing, and then bring the machine up online or what have you. There's work where the project is called, it's from the same folks, from UMass, right? Third I think. It is one of the references on this paper. Essentially, it's like the Russian, the doll, where smaller doll goes into bigger doll kind of thing, right? So their assumption is laptops are very energy consuming. So if you're just leaving it online to check email and stuff, right? So it'd be nice to have within your laptop a smaller device, which all it does is checks to see if you have email, right? Or some packets for you. If it finds out that it has email, then it wakes up your laptop to do some things. Otherwise, your laptop is in kind of a half asleep mode, right? So it's not the same as putting the whole laptop to be aware. Here, your laptop is asleep with this little device. So you can have like hierarchy of these things, sort of like the Russian dolls, where if the little ones find out that you actually have some work to do, that it needs to bring up the whole thing, then bring up the whole stuff. Otherwise, these little ones may just be enough. So for example, you can show if you have mail, you can show the heading from the mail, and you may choose not to wake up the whole laptop to read the actual mail, right? You may not be able to proceed further than that, right? So there's the philosophy that you can have these multiple levels of things where they all kind of cooperate with each other is one of the interesting philosophies, right? And again, so the two things that they talked about are environment monitoring to track exotic animals and search and rescue missions, right? Where you can deploy this within fire or something, trying to figure out whatever, right? And I added this last one as a baby monitor. Have things in your house where it's not constantly watching your house, but so how many of you used heard of Extend kinds of stuff? There used to be like a massive pop-up company in 2000 called Extend. They're home automation kind of stuff, so you can buy these little toys from them and control different parts of your house, right? Like from simple things, from lights that you can turn on over the internet or what have you. But they're mostly involved in home automation, right? So you've heard of them. You've heard of them too. So the idea here is you don't buy integrated system. You don't go and automate your house. You can do that, right? You can go to some company and say, I want the whole house automated. I want this nice interface where everything works and everything. And probably Bill Gates has one of those kind of systems, right? But the Extend is more of, you go to Home Depot and then you find that now you have baby, you want to do a little monitoring, so you have this little audio sensor, you buy them, and then you hope that it'll integrate with the other components. You're not trying, so these are probably, impulse buy in the $10 to $50 range. So they sort of work, but they're not going to be programmable or anything integrated with the rest of the stuff. But these are sensors kind of stuff, right? And unfortunately, we don't have stores like that, but I heard like in California there are home stores which sell these things, right? I would love to go and get this stuff to put together because looking at these things over the catalog is kind of bad. So those kind of applications could benefit from these too. So if you can kind of mix these stuff, right? Already there are sensors in your house. Like for example, if you have a garage and the garage door has a sensor, how do you integrate all of them into this kind of stuff? So when you walk into the house, the garage sensor notices that the garage is open. That means somebody is walking in. Then everything begins to wake up and starts to look for stuff, right? That's sort of the model, right? How many of you buy the two examples that they mentioned, especially from the recognition folks who?
I don't. Maybe not for technical reasons, but I'm just, when you start to look at what they're actually saying, it seems like for those two examples, one of two things has to happen. So, say in the environmental monitoring, right? You have these 3 tiers of cameras. It means that you have to either have the same number of cameras at each tier, because if you're waking them up, you need to be able to see the same thing, or you have fewer cameras at the higher tiers because they're more expensive, but somehow you have to coordinate the fact that they can look at the same thing. And especially for like search and rescue, where you're kind of deploying those quickly and whatever, it doesn't seem like you could even do that effectively. That you could have some smaller high fidelity, smaller amounts of high fidelity cameras that you can make sure are seeing the same area, which then leaves you to having all the cameras, having the same number of cameras at each tier, so you can see the same area.
So your concern is with the, so you don't believe that this will work unless you have the same number of objects in each one. And are you assuming that they're all like sitting on top of each other kind of thing, or?
Yeah, or that somehow you have to guarantee that you can see the same area.
Well, actually, I would say that you want more cameras at the higher tiers. You want to be able to, the webcam version, the cheap one, right, that's low power, tells you that there's objects out there, but because it's so zoomed out, it can see 10, 20, I don't know how many objects you want to say that it can see. But if you want to be able to track all those, you only need one webcam to be able to see the big picture. But then if you've got 20 people moving around, or animals, or whatever, you need one of those cameras able to track each person individually.
Yeah, those tiny cameras are like 180 by 180 or something. Like, that's not like the resolution of those are.
So we didn't even consider the other one that I kind of mentioned. I still haven't found the reference to it, the John Hopkins one, right? John Hopkins one, I think I mentioned it briefly, where for every pixel you have a little computing thing next to it, right? And it can do this the very simple thing they mentioned, which is like light change, then recognize, right? They're not focusing on anything. So the idea would be like you cover this whole wall with these sensors, and they're kind of looking out like a fly kind of thing, right? But any change they recognize, so they do. So that's tier 0 in their model. I mean, it's very integrated, very low power, and hopefully very cheap and stuff. So it's taking even worse than the 180 by 180 that you mentioned, because that's probably like 1 pixel by 1 pixel. So they basically say, so if I move like this, they can say that there's somebody blocking the light because now I see light change and everything, right? So are your concerns inherently on any application which can do video sensing kind of stuff, or is it more on the multi-tier model? Would having like a single tier?
No, it's not so much that. It's just that at some point you have to account for that, like that if you're buying the ability to save energy and only have really tiny computers and cameras up and running, that you lose something in the process, and especially if you're trying to say that you're trying to save on cost, you lose something in the process, and it's not clear that they explain how to deal with that, or
how would you deal with that?
I don't know, or it's not clear that they even.
What's your gut feeling of how you would solve that?
Well, the trade-off for me would be that you'd have to coordinate the cameras at the higher tier, which means that you lose the sort of ad hoc deployability. It's
yeah, the search and rescue missions I'm not personally buying. I don't know that the power argument, I can really relate that to computer vision, but I can say that this concept is actually a great one for computer vision, because you're not going to get, even with the high definition top of the line webcam today, you pointed out at the quad, you're not going to get sufficient resolution on people, even with these high definition cameras that are taking everything, to be able to recognize people. Most of the algorithms want more of a zoomed in, here's just the big image of the face. So this kind of a model works very well, I think, for computer vision, having nothing to do with power, just having to do with the way that they're capturing data. They're missing huge applications in security. I mean, there's tons of security related stuff. The Bush administration wants cameras all along the Mexico border right now. I mean, that's where this would be, interesting. If the system could actually look at the border and say, that's a border patrol agent, that's someone hopping a fence, that's so those types of abilities are actually a huge application. I think it's overkill as a baby monitor for toddlers.
Why?
Because I think one HD camera would give you everything you needed. Maybe from a power consumption standpoint, it's better, but from a computer vision standpoint, I don't think you need this multi-tiered approach to get a workable product. It might make sense from
so
a power
that's what I meant, like toddlers, meaning like they can walk, right? So
yeah, but I mean, you're not going to have this room that's so big that you don't have a camera that can cover it.
no, I mean like they run around the whole house. Right?
Well, if they're running around,
this kid run.
right, but if they're running around the whole house, it's not that you need a multi-tiered approach where you have a webcam and this and this. You are going to need cameras in multiple rooms that communicate, but a multi-tiered concept is different, right? You don't necessarily need that.
So you're assuming that running a camera 24/7 is not a big energy drain because you already have power outlets in the house, kind of thing.
Sure. Yeah.
Did they ever? Because I know when I played around with this FireWire camera, that you could change. There's like 3 different. There's the full resolution which is 480 by 640, and then you can go down to a quarter of that, and then you can go down to a quarter of that. Did they? I don't know if the power consumption changes when you go down like much lower, but did is there anybody investigating whether if you could start at a small resolution and then just change it if you saw a big difference, you could go to that high resolution?
My sense is like worrying about energy for all these things is a very new concept, and then worrying about energy for capture and you know those things are fairly new concepts, because till this point, right, most of the capture stuff was happening for your camcorder or something, right? Where even though the CCD is very very energy consuming, you have the other mechanical stuff moving. You have the whole unit moving a tape and all those things, and you have the big LCD screen and all those things. So it was not actually a big deal, right? How many of you worried about? How many of you bought a camcorder at all, saying I want a CCD or a CMOS device, right? And the newer ones are CMOS, like the ones on this laptop are CMOS, which consume less energy than the CCD-based one. They're not as good quality, but they're kind of working towards that one, right? So my sense is they're only thinking about energy very recently, because either they're going on laptops and stuff, and for other reasons. So it's highly likely that they take the 640 by 480, which is the one which is already comes out, and if you want to make it into a smaller thing, it just sends half the information, even though it collects all the stuff, right? So at some degree, you may want to do something like what you guys are talking in a different context, which is make them into like a number of different CCDs, and then only capture on one shot of everything within the camera or whatever. But I don't think they do any of those, right? And FireWire is not designed for energy, right? FireWire is designed for connecting two devices, and I think it was 48 volts and stuff like that. So you lose the whole thing right there.
Oh.
But so historically, I mean, part of this group wants to look at energy research in this context. So it's in some sense it feels kind of added on, because some of these applications, the energy may not be such a bad thing, right? For example, for the search and rescue, right? It's very rarely do you like search and rescue for a week or something, right? You usually kind of put those things in there. So if they have enough battery to last for the few hours that you're looking for, energy is probably not as important as the search, accuracy and all those other things like you mentioned, right? Because most scenarios it's either do or die within a couple of hours, right? And if you're not rescued, it's very rarely that all the firefighters are there. They go off, and after a week or something, you suddenly see a person walk out from the rubble or something, right? So energy is probably not a big deal there. Energy is probably a bigger deal on the exotic animal thing, but it may be such a big deal that this is not the right approach, right? For example, if you want to monitor, I think there's a project at Princeton trying to look at zebras in Africa, right? So you probably don't want to put the sensor and move it every so often, right? So you probably want these things to be sort of behave like the Oregon coast thing. So it's going to be there, it's going to be running for a while. So you need to have enough lights or whatever to keep them going. So energy may not be an issue. So that it's an academic paper. We have to get papers published. So energy might have been added there, right? In terms of the what you need for recognition, all those things, I think in some sense they are like jumping ahead of where the technology is, right? You want something which can recognize and do this thing and jump to figure out what the stuff. So even if you can put good cameras and stuff, is the recognition good enough to make this all happen in real time?
To do it, well, that becomes a very complicated question. I mean, it's what are you trying to identify? Are you trying to say that there's a tiger there, or are you trying to say which tiger it is, right? I mean, the exotic animal case, because those are going to be two very different answers. I certainly think it's possible to say that there's a tiger there in real time. But the other thing is, I mean, there's going to be a lag. So I mean, it's a question of, are you going to need a quad core machine, or are you going to need 16 quad core machines? I mean, the task is doable in real time, even for identifying which one it is. So it's really just a function of how much computing power you're willing to throw at it, and how much of a lag. I mean, if you're looking for within a millisecond of the frame being captured, knowing this information, no, it's not going to happen. But for most of these applications, if within a half a second, if there's a half a second lag, it's processing everything. If there's a half a second lag, I would think that that's fine.
So does that answer your question? Like the real key is in the recognition component.
Well, the other thing is if you're looking for global power consumption, right, this is probably a drop in the bucket, meaning the power to run a quad-core machine per each one of these tracking units to analyze everything is probably going to dwarf the power needs.
Oh, but the point is, their point is if the tier 0 or 1 doesn't recognize any movement, right?
Yeah.
Then the quad core is just going to sit idle.
Right.
And it's not even going to be on.
Okay.
Right. I mean, their point is precisely that if you go with the one tier model, right. Your quad core has to be idle. Whereas in their model, the quad core can be shut off. Right.
Right. But I'm just saying it also matters where you're going to put these quad core machines. Are you going to have them where the camera pod is, or are you going to have a central data repository where all of the data goes to them? Even from a power conservation standpoint, that's probably.
So there's on a different note, not related to this particular course, but in general, the energy stuff, right? A lot of the it's assumed that if you have a power card somewhere, then energy is kind of free kind of stuff, right? But there's a lot of push within the industry and stuff to make your normal house be energy aware, right? Because apparently a normal house when it's idle consumes so much energy now, it's no longer a background noise, right? I mean, you have so many things in your house which are just idling, not consuming enough energy for you to notice, but enough for to make a difference, right? So at some point you have to worry about these things running because, maybe they take like 50 watts, or something, right?
Well, I mean, if in your house, your TV listening for the on signal, the infrared listening for the on signal, actually uses way more power than people realize.
Yes.
I mean, it's something like a 20-watt light bulb or something like that. I don't remember exactly how much power it is. But your TV's sitting there doing nothing.
Yes.
And it's not just your TV. It's your DVD player. It's,
and your set-top box and all those things.
Yeah, I mean, everything that uses infrared is using
So there's a push to make these devices be more aware of the energy constraints, not just because, within the US economy, the energy is so cheap that you don't have to worry about these things, right? But it's still maybe like $10 a month to your electricity bill or something. Still, if you can avoid it, it's a good thing, right? But the TV is a good example, right?
Yeah.
TV when it's on actually consumes so much energy. It's not people don't even realize that, right? Like your big screen TV probably consumes like 200, 300 watts to run. But at least that you can forgive because you're hopefully watching it.
You're using it. But I mean, if you have 4 TVs in your house, let's say, it's like 4 20-watt light bulbs. Just listening for the remote.
Most houses have the garage door opener which is doing the same thing. Your TV, your VCR, your DVD, and all those things which are waiting for your stuff. You're not talking about not having them wait for you, but making that more energy efficient, right? Rather than so inefficient. So that argument, people would like to change that. So the argument that you have multiple cameras within a house keep running all the time, right? I also think that the other example that you gave, that even if you have HD, that you can't see much in the quad, right? It's more to do with the processing, right? So if I give you instead of 1920 by 1080, if I give you 1920, 100, multiply by 10 on each axis, like that much resolution, right? Then you can process through and figure out, see human, people and stuff without zooming in. It's just that you would probably need 10 quad core to figure out what's going on. The data rate would just kill you, right? So their design the paper is well written, I think, in terms of the arguments of what they want to do, right? One is the move these things to the least thoughtful tier, and which is what they were trying to go for, right? So obviously in the the smallest tier, it can't do many of the things you talked about. And exploit this wake on demand, which kind of fits in with the other paper that I mentioned, and exploit this redundancy in coverage. Where if you have multiple cameras and what they see, try to use that, right? So, but I feel like they've handled a whole lot in terms of how these things happen. So, for example, in the case of trying to figure out what is background and stuff, right? So they during calibration they take a picture and assume that any change from that is motion, right? So the lower level sensors assume that, right? So to me it sounds kind of like if you were to look outside, right? You constantly kind of take these things every so often, because otherwise, night and day happens, so there's things happening. So it's very easy for the tier ones to detect events when there's none, right? And that's inherently because they're not smart enough. So the cool thing about tier 0 or 1 is they're not smart, but they're very less energy consuming, so they can be funky. But it also means that it's very easy to trick them, right? So you have to develop mechanisms where the calibration happens over the time, right? So you know what you should worry about, what you shouldn't worry about. So if you see rain, then you should figure out that's not a change that you should trigger, because otherwise this whole thing is going to be fired, like a July 4th kind of thing, right? Because if you see rain, then it's going to see that the sort of change, so it's going to trigger all the other layers in the whole system would kind of, the whole system. So the upper levels know that nothing is going on, but they're going to be constantly interrupted by these lower levels, right? And they didn't talk about any of those stuff, and you have to forgive them because they're the first people to get into this kind of a space.
Well, I would think rain is gonna. I don't think there's a way around that. If you still want to be able to track stuff in rain, you're gonna have to have everybody awake all the time. From a computer vision standpoint.
As long as it's not probably that's the only way, right? There's still research to be done, right?
Well, that's fine. I'm just saying, if there was rain, all the techniques I can think of for using the low-res version to be able to detect if you need to wake up the high-res versions, the low-res can't do it. Mm-hmm. You're going to have the higher tiers awake all the time when it's raining. I don't think there's any way around that.
So that
unless you want to just say it's raining, so I'm going to not pay attention.
No, so you may require different sensors, right? So if you assume that this is a deployment which is trying to do something like outdoor warfare or something, right? You need to have other sensors to make that happen, right?
Yeah. Can you just have something that senses rain?
Yeah. And then runs a different algorithm which
No, I'm saying I don't think with an optical camera there is going to be a different algorithm that can differentiate with such a low-res version what's going on.
Okay.
Yeah. So you could maybe try and use, I don't know if infrared can see through rain, but if you could use infrared, I would think that's actually the smarter way to go for the low-res version anyways.
So the thing which interests me is once you build this stuff, if you build this multi-tier, right? So the nice thing is the lower tiers are dumb, right? That's the thing that they like, right? But the hard part is since they're dumb, they probably are going to be dumb, right? So you need to develop these other things which maybe IR, maybe what have you, right? Something to figure out what's really going on, because otherwise every time when the day changes, you're gonna have these things trigger, so lot more work needs to be done in this kind of arena. Like if you want to deploy this, how would you do this stuff, right? So so in the case of an enemy or something, right? So if they send a smoke, right? So you don't want to just look for rain. You may have to look for smoke or fog or all those things, and how they interact with them. It's open for research. Right? So anyway, like let's look at 2 slides before I go to the summary side. So the paper talks about what are the issues involved in each of the levels. So if you look at the tier 1, the experiments, they use 2 different cameras with 2 different with the same processor, and one of them consumes less energy but it takes longer. One of them consumes more energy but it's faster, right? But I suspect that all of these are the few people like Panoptes and these people are the ones who are asking these companies how much energy do these things take, right? I'm not sure how many of you actually, when you bought a webcam, asked for what's the lower energy consuming stuff. I don't think anybody cares about energy. I don't think they mention about the energy and all those things. But these people, so the new researchers are trying to push in that direction. So maybe if you have more integrated platform, like something where the processing and the camera are built in, you could get more energy efficiency, right? So in this case, it takes them like 892 milliseconds, almost a second, to detect very simple thing, detect the best objects, right? And I don't think you can see this stuff, but there's table 2, which talks about the different sensors and what the capabilities are in the paper. Right? And tier 2, again, you probably can't see it, but it takes like almost 4 seconds to detect something at the tier 2 level, at the more powerful processors to, in terms of the energy consumption and the time it takes, it's a lot higher because you have to have the machine boot up and do certain tasks to do the analysis. If you enter tier 3, booting up the machine and getting it in a state enough to make a recognition is going to be slower, more energy consuming, what have you. And again, I don't think you can see this. If this is your table 6 and 7 in the paper, essentially where they compare this, the tier 1 and multi-tier based approach. And as you would expect, the single tier approach would have to compromise on stuff, so it always consumes the same amount of energy. Whereas in their system, the Panoptes would be the tier 2, right? So in the case where the tier 2 can be turned off, you save much energy, right? So the results are not surprising. The results is what you would expect, right? Because you have these different stuff, and you hope that they will do the thing. So in terms of the sensors and recognition and all those things, so I hope to for at least for people who are grad students, that I think multimedia is like, it's a very rich area for research, because like my assertion is, without multimedia, without this kind of stuff, most of the problems go away, right? Your laptop is probably fast enough to use VI for now. So in terms of energy and all those things, multimedia is one which kind of pushes these things. But the interesting part is, now with the processor speeding up, you want to do stuff where all of us can look at this and go like, that's quite dumb. I want something more, right? For example, with the TV project, right? It seems so simple, but it sounds so horrible, right? But in terms of the image that you looked at and stuff, right? In terms of what Will was pointing out, I believe what he was pointing out is good, that you want to have more cameras, better recognition, all those things. But sort of putting these together into a viable system which can do something, sir. We don't know what that is, right? I suspect that nobody really cares to see that there is a tiger. I think they probably want to know whether that particular tiger that you're tracking came back or what have you, right? And to implement that, probably you need better cameras, probably you need better algorithms or what have you, right? So the people who are going out there trying to deploy these things and trying to go on the cheap by putting a webcam or something to figure out the zebras and stuff, and you look at those and you go like, I don't think this can work. I mean, probably the webcam can probably say that there's a human being walking across. That's essentially what I saw when I was doing tele video, right? All I see was like this like bunch of 4 people, which is probably not enough to do any kind of rescue operation, right? But I think in terms of changing recognition algorithms to fit this kind of a world, right, where it's not more recognizing terrorists and all those things, which are interesting problem. But in terms of what kind of a device, so how do you add device constraints? You probably can't take a quad core, like you mentioned, into the jungle to put them on the stuff. But I think this kind of recognition algorithms would be really interesting, especially for the people who are working with the sensors and all those things, right? Because they are not recognition people like you talk to Clara and all those things point out. They have high hopes, but with the background, right? So, for example, the thing you mentioned that rain cannot be, you cannot fix rain, right? Because rain is inherently a very hard problem, right? None of these approaches, I don't think they understand the complexity of it, right? Even though these folks did talk to some image processing folks at UMass, I don't know if you knew that person, right? It's an acknowledgement section, right? But I think if you could, any of these applications are going to make a lot of difference, right? In terms of your laptops and stuff. Like I pointed out, like if you have your laptop constantly watching you and doing stuff for you, right? People we're always saying that this will be nice. If it looks to see that you're angry, because you can do. Is that easy to figure out?
If someone's angry?
Yeah. Not one single person, right? You.
Yeah.
Right?
I don't know that there's a lot of work on that from a facial expression standpoint. There's a lot of work on being able to deal with different facial expressions, but not that I'm aware of on identifying what the expression is. Do you know of anyone?
Isn't the AI lab kind of looking at that? Robots?
Yeah, there are people looking at it, but I don't know if there's anybody who's done it.
So these will be in the context not of anything else that like would have been considered technically challenging, right? This is more in the context of your laptop sees that you're angry, right? And it does something to make it more soothing, right?
But who wants that?
What?
Who wants a machine to make you feel
Like a
better?
friendly robot?
No, maybe it makes it look like things are faster. Or whatever.
But then you're going to have problems like in Hitchhiker's Guide to the Galaxy, where they have these friendly doors and they always are very friendly to you. It
That's
really gets
patronizing.
annoying. Yeah, it's
I don't need my computer patronizing me.
Basically, I've heard rumors that the people who use the say one if you want to talk to, and you can actually say it. I've heard rumors that they actually are doing like stress analysis on your voice, so that if you sound really mad, it'll get you to a person.
I don't think it works because I get mad because he doesn't understand my accent at all. And I'm like, okay, help, right? It's like say 1 through 5, right? What do you want? 1. I'm like pressing 0. It's like, press 1, 2, 3. And, say 1 or 3. And I'm like, oh no. The worst part is say your name, right? It's like, okay. Go through
Bob.
this again, right? Can we just get through this and go this?
Yeah.
Like,
Okay.
say
Well,
your
certainly
name,
they would like
say
to be able to do that. I mean, how much that's actually going on, I don't know. But they would clearly like to be able to tell that you're getting ticked off and transfer you straight off.
And then they say, hey, let's leave them on for a little while longer. Let me get even more pissed off.
Yeah, like those, right? So I'm saying that recognition not in the context of detecting enemies and all those things, but recognizing in the fact that, okay, if your laptop doesn't thought that you're angry, but you're not really angry, right? It's okay, I mean, because it's not life-threatening or something, right?
Yeah.
But like some little things like that being added recognition algorithms which make
Well, it's a very different problem than recognizing who someone is. So
yeah, recognizing what the expression is because you're trying to do somewhat a decent job, right?
Yeah.
And in terms of the recognition along this axis, they're not trying to do the best recognition possible, right? They're trying to do the best recognition possible within the constraints of the device and stuff. So algorithms where your constraint is it has to be real time, right? It has to be within. So in the case of the animals and stuff, I would think that you would want to recognize within a split second because then you can start tracking, right? If you take a while, I'm guessing most animals would run away kind of thing, right? So I'm not sure how much of the vision people actually do this kind of stuff, but if you kind of mix these things, there are a whole bunch of interesting applications are possible, right? So hopefully, so that concludes this lecture. I'll see you guys on Thursday.